So in this class, what we wanted to do was, first thing, learn few basic tools with one intention, that is converting our ideas to products or a solution. So what I mean by that is, uh, say we want to build a particular kind of robot, or what you see on the screen, like, it's actually a rocket nozzle that I was designing with one of my students. Uh, so uh, we, we came up with the concept. Uh, we delve deeper into the engineering principles of it, even though it looks a very simple shape, as you can see, like, this is the exit port, and this is what connects to the engine or the fuel side of the rocket. We had to go through the details of figuring out this profile. As you can see, there's a, this side of the nozzle is at a particular angle, this side of the nozzle is at a particular angle, there is a specific length on this side, there's a specific length on this side, there's a like, there's a call out for the diameter of this. So there is a deep engineering thinking, which is, as well as analysis and verification, which is based on the physics of the rocketry. So uh, so this is a product, actually this is a sub product of a product, like, a hobby grade robot and its nozzle. So uh, let's just start with you. I mean, how about just just think about it, like, if you are given a challenge to develop a product, what are the things that you would consider when before you start to design and develop that product? Akshay, you may want to take a chance, like, what do you think?
So
Say,
what was the question?
yeah, go ahead.
What was the question again?
Question is, if you are going to design a product, okay, if you are given a task that, okay, either you or you working in a team are going to design a product. Say, consider, uh, you can pick your favorite item, or say I could give an example of a car. So, like, okay, you are, I know that car design is much more complex, but still, say if I tell you that, okay, I'm giving an opportunity to design a really cool, awesome car for next generation. What are the things you would consider before you start to design the car?
Would like consider like the dimensions and like what would be like the design of the car that I want and like
Mm-hmm. Krith, what do you think?
Well, the different factors that I like want in the design of my car, what I'm aiming for.
Hmm. Okay, so let's start to dive deeper into this aspect. Okay, say, okay, what does the car do? Car takes people from point A to point B, like, say from your home to school or whatever. Then there are multiple vehicles, many different kind of vehicles that can take you from point A to point B. Even it could be even golf cart for that matter, that can take you from point A to point B. But there are few specific or peculiar things about the car that probably golf cart won't meet. Or, even bicycle can take you from point A to point B, but they do not meet uh, certain requirements. That is why you are going to design a car to meet all those requirements. So first thing is capturing uh, the requirement, which is, okay, I want a vehicle that can take me from point A to point B, which is from my, say, home to school. It can drive me from one town to another. It should be comfortable to sit in. It should be safe, and not just me and my family. I should be able to put. I should be able to carry some items also with me. At least basic grocery. I can fit three or four suitcases in it. Then uh, it should be. Uh, then comes the next thing, which is It should be able to give me, it should be reasonable priced, you know, and then the fuel that it should use should be commonly available. It should not happen that fuel on which the car runs is only available in Dallas and you reach to Houston, now you cannot find the fuel. So yeah, the car should be able to accept the fuel wherever I go. uh, it should keep me warm in the winter and keep me cool in the summer. So all these requirements you list down, and from there you break it down into individual components that, okay, well, to take it from point A to point B in a safe manner, I need certain kind of wheel design, certain kind of engine design, and that engine design will drive like, what kind of uh, uh, and based off that you will decide the vehicle, the uh, like fuel that you are going to use, to add other features such as, like, and as I said, it should, in addition to, you should be able to sit, excuse me, pardon me. Yeah, yeah, in order to sit comfortably, I should have seats inside it. In order to put the items in it, I should have a little trunk space or something like that. And then maybe to keep it warm and cold, I should have a heating and cooling arrangement, something like air conditioning. Maybe I can put a rack space on the top, and then uh, my vehicle should be able to take me from city A to city B in reasonable time. Like, I don't want to go from Dallas to Houston in 2 days. I want to be, my vehicle should be able to take me there in this much time. So all those requirements you list down, and then you start to tackle individual items. For example, the design of the wheel, design of the engine, design of the seat, design of the trunk, and then how everything comes together, and the body of the car, uh, uh, like what and all it should be able. So with that, I think uh, I would like to identify couple of small scale products that I would like you to work on as a part of this project. So the first part is going to be the design. It should be achievable. That means, I mean, even though I gave an example of a car, it will be within our limited resources and scope. It will be very difficult to build a car. So let's think of a small product. We come up with the specification. We come up with how it is going to look like. Then we are going to come up with the pieces which will be required to make it. We are going to look into where can we get those pieces to make it. There are few things that we may have to buy from the shop. There are few pieces that we may have to manufacture ourselves, maybe using 3D printer, maybe few machine pieces. Then we are going to assemble it. Then we are going to test it. And then during the testing, we are going to give that item which you are making to a true user and ask them, how do you feel about this product? How does it feel? Is it comfortable? Is it truly solving the problem that we set out to? And if they say good, that means our product has been successful. Additionally, we also have to ask, this is the price, or this was the cost of manufacturing this product and making it available to someone. And is this cost reasonable to you to pay for? And if it is reasonable price, then that means our product is successful. It meets the intent, it meets the price, and customer is happy with it. So with that, uh, let us let us start thinking about something that we will design, make few sketches so that we can discuss in detail and we'll start to work on it. But as an exercise, uh, I would request you all to you know, take a piece of notebook. I mean, take a notebook, take a pencil, and uh, write down about a product and think through, like, all the aspects which I just mentioned. Okay, and then we'll discuss about it. Is that good?
Okay, but what should the product be?
you think of it. Say, let's see, as an example, let me share something here. Okay. Okay.
Can I go get a notebook real quick?
Uh, uh, yeah, do it, but just give me a minute because your friend asked a question. Can you see my entire screen? Here, let's see this. Okay. Say I go to Amazon. Okay. Amazon.com. You could even consider, like, say, there are 3D printers. There's this. How about let's think of a small, sorry, learning robotic. You all. So here are some few examples of, like, a robotic kit for learning. Okay. Uh, you can think of something like that. Or actually, there is even a small rocket. Also, learning kit, like, somebody has designed it two pieces, put four motors on it, put an Arduino and sensors, things like that. Or we can also think of, say, okay, uh, injured knee assistance. Like, there are kits around that. So see, there are all kind of products here. Say, for example, you might definitely would have seen these kind of thing. For example, this over here, a person has to, this product helps them with the mobility. This product provides some support, and just think through the design of, through the design of this one. So person, like, cannot, they find it as they are going through the, recovery or knee injury, as they're recovering from it, they may not be able, they should not put a lot of load. Can you see my screen?
Yeah, I can see your screen.
Yeah, they should not put too much load on their knees. So this product helps with them. Again, so there are a bunch of thoughts. It is a lightweight system, so that person can move it around. It's pretty lightweight, and as you can see here, uh, it's a very stable. So they put four wheels on it. Then I don't know if you are noticing, there is a little cable here that is going. You see that there's a little cable running all the way here. So in case it starts to go out of control, you can apply a brake. So, and then for, in order to support the knee, you got this little pad here. And then since you have such a good structure, so somebody said, like, well, you can put little grocery, small items also. So they put a little bag also. So there was a whole thinking that went through it. And as you can see, it is extremely simple, and probably cost effective too. So each of these wheels will be about $5 to manufacture those big wheels, $2 to manufacture small wheels. And then this steel structure may be about 50, well, manufacturing cost will be about $40. So within 100 $150 you get this equipment. So that's one product, like, obviously it started with a requirement, and from there somebody, like, took it. And there are so many other things, or even knee pad for that matter. Okay. So does that give you a good idea of, like, uh, uh, how to think about a product? uh, or you want me to walk through some other examples too?
That's good.
Okay.
I
So
understand.
got it. Awesome. So uh, let me just take a pause. You go get your notebook, and I will give you about 3 to 4 minutes to sit down and think through it, and then you talk me through the whole process which I suggested. Okay. So I want to, at this point, I just want to confirm that we have understood the path to product design, and then I will let you take your own time and, think through the detail. You can even change your product that you may want to design. Okay. So go
So
get your
right now
notebook
we're
and
just thinking of a product we can design, or
yeah, think of a product, uh, small product, like, that can be used for solving problem. And then I want you to walk me through all the aspects of it. Okay. The cost, the problem it is solving, what are the features it will have, how can you keep the cost low, and once you make the product, how are you sure that the product is successful? Means you make something and people use it, that means it's successful. If you make something and people cannot use it, it's not successful. If you make something and people you can use it but it is super expensive, then it is not so successful product. So think through all those aspects. Okay, so go ahead and get a pencil and notebook, and then we will I'll give you about 3-4 minutes, and then you can talk through your product. It could be anything, a special kind of pencil, a special kind of equipment, a sport equipment. It could be juicer, mixer, grinder, or even a toy for that matter, or help people with limited mobility and all that. Okay, so go ahead. So we time right now is uh, uh, 1:51. So we in your place. So we will meet at 1:54. Okay,
Okay.
1:54. Uh, so are we good to discuss, or you want some additional time? Just checking on the time.
I think I'm ready.
Okay. Okay, sounds good. So go ahead.
So my idea was kind of like a trash can that separates trash from recycling, because a lot of people just put it like in public places, just put trash and recycling in the same box.
Mm-hmm.
And the way it would work, so there would be like one big bin,
Mm-hmm.
and then all the like someone would put something in, and it would fall on a table, and
Right.
a camera would like use AI to recognize if it was trash or recycling, and then
Okay.
it like the tape like the box would flip over to one side, either
Mhm.
put it in recycling or trash.
Okay. Oh, that's a really good, amazing. I mean, a lot of details you provided. So let's think of all the components that we will need to build something like this. What are the units that will be there? Approximately how tall? I mean, you do not have to tell in meter or feet. Like, it should be waist high, or up to the chest, or what should be the approximate height? How big it may be, and what are the individual modules which will be needed?
So I think it would be about the size of two regular trash cans. I'm not. I think
Mm-hmm.
that's like maybe so maybe 3 feet and tall.
Okay.
Uh, 3 feet tall, 2 feet wide, and 1 foot thick.
Okay. That's reasonable.
And then
Okay.
the
Yeah.
different components.
Uh-huh.
First, there would be like the whole, and then there would be two parts: the
Okay.
top layer and the bottom layer. And the
Mm-hmm.
top layer, it would be like a table.
Okay.
That's the part that flips over to either side.
Okay.
That would be about 1 foot of the height, and
Mm-hmm.
then underneath that there would be a trash can and a recycling can.
Okay.
So the table, so once you drop the like either trash or recycling in the hole, it
Mm-hmm.
would fall onto the table, and then there would be a camera in that area as well that would recognize, that would be connected to like a battery source or something, and
Okay.
it would recognize it if it was trash or recycling,
Mm-hmm.
and then it would send the signal to like the table thing, and it
Okay.
would probably use some kind of gear mechanism to flip to either side for trash or recycling.
Okay. Okay. Um. Uh. Very good. So it will have camera. So actually, to drive the camera and recognize or run your AI module, we might have to put a small computer or something like that. Actually,
Yeah.
even Raspberry, something like Raspberry Pi should be good. Very good. And you suggested that camera will only guide. There's nothing happening automatically. Is that right?
What do you mean by that?
Means to move the trash, the camera will tell what goes to recyclable and what goes to regular trash, and then person is going to do it, or there is
No,
something.
like, see where the trash recycling falls. It's like
Uh-huh.
like a turntable. So
Oh, I see.
once
Okay.
it recognizes, it moves to one side, and that slides into the either trash or recycling.
Oh, wow. Very good. So that means something like that will then, if it is a turntable kind of thing, it will have a motor which
Yeah,
will
like
move it
a
to.
gear mechanism or something.
Oh, that's great. And then obviously you would like to put this whole system on wheels so that you can take it from one point to the
Yeah,
other.
it'd be
Okay.
like in public.
Yeah, that's good. Very nice. And what would be the price range you would think about it?
I
That you
think
would
it
think?
would cost about $300 to $400 to produce,
Okay.
and
I
we
think, yeah, that's very close to what the actual cost will be. Very well thought. Okay. And the material for the trash can, metal or plastic, what would you consider?
probably some kind of cheap metal, and not something too like powerful. Maybe some thin stainless steel or something.
Okay. 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 Uh, okay, that's nice. And you would put it outside the house or inside some in facility, some
Well,
kind of
this
inside
could
or yeah.
this could be used anywhere. You can put it in house, in public restaurants.
Okay, got it. So I think the material that we will choose, if we are going to choose a metal, either metal has to be painted or have a special process so that it doesn't start to rust because
Yeah,
it will see air and or yeah.
yeah.
Yeah, and metal will be your preference because of the strength needed. You suggested.
Hmm.
Okay, very nice, Krit. Good job. So yeah, uh, this is I'm extremely impressed. Like the kind of detail that you thought through it. So I would like you to make a little sketch. I would like to all the features that you talked about. Write that down. I would like you to label all the features in the
Okay,
picture that you make. They're like with an arrow. This is where the camera is going to be. This is where the wheel is going to be. This is where the turntable is going to be. So
yeah, I can do that.
maybe if you have to make additional sketches to explain the insides of the trash can, how it works, let's do that. Okay,
Okay,
and uh, prepare it on a couple of pages, uh, and whatever is convenient for you, whether you can write everything with the hand and sketch everything with the hand, great. If you can do it with the in word or something, that is also all right.
okay,
If you can send it by next week, uh, either to my email or on that WhatsApp, that'll be great. Okay,
okay.
or uh, if you want to uh, as I suggested, like or you can apply this thinking to make another product if you can think of, that is a fine too. Okay,
Okay,
and
can I make it in on shape?
oh yes, that'll be perfect, that'll be great. If you
Okay,
can do it in on shape, that's awesome. Okay, and you do not have to and like have everything perfectly and for more, if you want to put motors and camera and things like that, you might be able to get a step file. Remember last time I showed you McMaster?
yeah, you can just like download stuff files off the internet and
Yeah,
upload them
yeah,
into Onshape.
yeah, exactly. Great job.
Yeah, thank you.
Sure. Akshay, what would you like to share?
I haven't really thought of an idea yet, cause like
Okay,
I was yeah, but
okay,
the direction I was trying to go in was like I was trying to make like I was thinking about like a device that helps disabled people pick up stuff.
okay. So okay, sounds good. So what kind of stuff? Like, uh, somebody's wallet,
Um,
credit card falls down, or what kind of things?
I mean like daily like everyday things. Like normally they need like some sort of assistance, right?
Uh-huh. Yeah.
So like a device that could help them do stuff on their own, basically.
Okay. Got it. Got it. So would they carry that device all the time, or if something has fallen, it's the device is sitting in corner in the house, they walk up to the device and take the device and pick it up? How do you speculate that?
Well, I and they're for like people who have like a walker, like you use like a walker to get around. So like it'll be placed on top of the walker, like
Mm-hmm.
and then whenever they need to like help with something, the device would be on the walker, so it'll be with them, so they can use that, or maybe like on a walking cane or something.
Got it. Got it. Got it. So definitely you want it to be extremely lightweight. Uh, so the grabbing itself, you want them to control, or you want it to be automatic that, okay, they just push a button and then that item will grab that object. How do you speculate?
Uh,
What do
it
you
would be
think?
better if they control it, because that way they can like pick that stuff up on their own. But at the same time, if they don't have like good vision and all that,
Uh,
uh, then then maybe automatic is better for them. Like maybe there could be two variations of it.
okay, okay, got it. Okay, okay. That's good. Anything else we can think of? What kind of material it might be made of, and approximately what should be the length of this thing? Any thoughts on that?
I was thinking it would be made out of aluminum.
Mm-hmm. Because yeah, aluminum is lightweight. Nice
Yeah,
thought. Okay.
and yeah, and then like yeah, maybe like we can like put like an automatic version. Maybe like there could be like a camera on top of the device that can like see what fell down and like pick it up using AI once again.
Okay. Okay. Sounds good. Uh, okay. So it will have a camera and aluminum based uh, like equipment, and that will be actuated by a person. But if we are going to use AI to help it, so AI will recognize the object, and based on that, it will help the person pick it up. So that means you will start to motorize it now. Is that right? Otherwise, whatever AI can see, that person also can see.
Yeah,
Yeah. So
basically.
yeah, probably it will. You would like to motorize it, and then it has to be lightweight, as we agreed. It will be connected to the mobility device. Okay, that's good. What is the price point that you are looking at? Like, what will be the reasonable price for something like this? And we can make
Um,
it very fancy, but if it is expensive and most people cannot afford it, that's different story.
I was
But
thinking around like 100 to 200 bucks.
okay, $100 to $200. Okay. Yeah, I think
Yeah,
it should be doable. Yeah, a motor for something like this, maybe $25. Some controls, if we put about $5 to $10, then yeah, you will have to put some kind of battery or power supply on it. Then the aluminum structure itself, I think, yeah, it is perfectly doable that way. That's good. Okay, so the same for you. For as a project, as a part of project that we are going to do in this course or in this class that we have, I would like you to design a product. Then exactly the same thing which we discussed with Kret. Go ahead and make few sketches with the arrows point to the features that the product will have, the items which will be required, the problem it is going to solve, and how we are going to qualify it. Like, we make an awesome product, and how we are going to qualify. We are going to qualify in two ways. First, the user uses it and they are quite comfortable using it. Second thing is, definitely it meets the price point. It is not very expensive. Uh, so that will qualify our product. That's good. Okay. Uh, that makes perfect sense. Now let me show you a product here, which I was thinking of actually. And this is much more complex, so we can ignore that part, but I just wanted to share it with you to get an idea. Where is my screen present now? I'm going to pick a specific window here. Let me hide this. Hide. Just give me a second. And this is so. Oops. No, no, no. I we lost its. Hold on. Control Z. We lost the seat on it. Here we go. Yeah, I think it's just because of this comfy. Let me see. Oh, it's hiding the whole seat. Okay, sure. Yeah, that plane was a reference. So somebody, you I'm sure you would have seen a rickshaw somewhere. Have you, like, maybe movies, maybe in real life, or maybe uh
yeah, I seen one.
hmm? Yeah.
I seen a rickshaw. Yeah,
Okay. So this person, I don't know if you all go camping or not, but like, there are a lot of camping enthusiasts. So this person, he tried to make a very eco-friendly, uh, like, a camper. So, and he used a platform that is based on, that is very similar to a rickshaw, and actually it is assistive. So they said, okay, I'm going to design. Uh, so through this product, we are going to walk through everything that like the whole thinking that went with it and what material that he chose and things like that. So you can all see my screen, can you?
Yeah.
Okay, good. So he decided that he wants to make a low impact, cost effective, uh, camper. Uh, so uh, very biking enthusiast. So he went ahead and modified the biking frame. As you can see, the typical features of the bike. You have the gear. You can adjust the speed here. You might remember like whether it's chain and sprocket or whether it's a gearing. Uh, if you reduce the size of the gear, you reduce the speed, but you are able to improve the torque. So if you are going uphill, probably you will engage the chain with this. If you are going even surface and want some speed, you can use this sprocket. So what typical bikes have? So here's that system, a water bottle, the mobile unit itself, and then there's a whole frame, and then few other things. You see this whole disc and braking system, disc and shoe braking system here, disc and shoe braking system here they put. And then so that if they're traveling long distance, uh, here what they did is, I think I was not shown here, but uh, yeah, probably no, no, actually he did not add that. It is entirely manually pedaled. I thought like maybe that's a battery, but and then here is to connect the sewage in case you are in the middle of the forest or something. Then comfortable seating, lighting. They put some handle here. So with this, in case you have to remove this panel with the help of this handle, you can remove it and see like how detailed thinking this person put in. Like in the night if you wanna sleep in it, so they have put little air vent here, and then the back
Is it
side.
possible to see the interior of that?
Yeah, we are going to see that also.
Uh,
And then they have shower head, soap, and all sort of things, and then door. So let's see. Okay, let me see if I can create the section view. Pretty cool. uh just a second. Oh, sorry, this model is very heavy, so it's taking. Okay, so that's l- it's a multi-use platform. Sorry, it's just taking some time before it I can you know that multi-use platform. uh, you know this is seating arrangement. They can work on the computer. They put little flower also, little curtain for privacy. And let's see the other side actually of this. So yeah, obviously this is the door and this is the window, and then here we are going to see from this side the section view. Yeah. Just bear with me as it is. Okay. Oops. Yeah. So as you're seeing, like this is the place to sit down. That is their table. And maybe what may not be shown here is that they may uh, they may in the night, like you can connect or bring this to this level and you can have an entire bed, and potentially you can use this surface even for cooking and things like that. So obviously it being human powered, uh, we can't make it super fancy, because every facility that you add to the system, it will become heavier and heavier and maybe costly too. So probably the material that the person might have used is like in a very thin plastic sheet or something like that. one thing that you should see is like, to give the strength to the structure as it is, you see, all around they have used like, good steel or like, aluminum tubing, you see, in these corners. So the core of the structure is strong, and they have then added just very lightweight walls here and here. And even this is, you see, this is a foldable structure, so you can fold it. In fact, if you push it up and pull it down, it becomes like, it closes your window as well. uh, and the the latch on the door, it's a lightweight door as well. So, and as like, thinking about the bathroom, like, he added bunch of features here. I mean, I don't know how much of it will be really necessary because it will add to the additional weight, but they included that feature as well. So pretty well thought through product, as you can see. Accessories is one thing, but like, the detail to which they went of designing the brake and steel structure, and then uh yeah, this cable here, the lighting in the front, water, uh, and then this handle to remove the panel if you want to remove the front panel, the very lightweight door. And if you see, like, they went all the way to extent of like, if a person has to come down out of they have even put the pedal here, like, foot pedal, like, pedestal, so you step and come down. So all those things, so the extent of thinking that the person has gone through. In fact, what you may not notice is, yeah, even this system, like, so that entire body can be attached to the basic frame. So, these are the fastening structures, so everything. Okay, so I just wanted you to uh, show you this example so that you can think of, like, the extent to which the typically you should go when designing a product. And you see, like, just to get a reference, this person has even put a model of a computer to estimate what should the size of that shelf should be. Okay, maybe we can look at the section from. And also, I want to draw your attention to the roof. If you see the roof also, there is so much thinking even in the design of roof also. See, it is not a flat. You could just, it designing becomes super easy, like, if it was just a flat. But what they did is they made it curved. Can you guess why?
Maybe aerodynamics.
Yeah, definitely aerodynamics. And other thing is, if it rains, if it was flat, little dents on the top could collect water. But if you have something like this, water will just fall off. No, water
Yeah.
will just slide down right and left. So again, like, it's a well thought through product. I don't know if somebody even made. I saw on YouTube somebody had made things like this. I think somebody in Canada. I think he traveled from one end of Canada to another on the bike, and he made something. It wasn't as fancy as this, but yeah. I mean, what I wanted to emphasize was, like, uh, the well thought through process in choice of material and structure and utility, and potentially the cost also. So something for like this, if you put it all together, I think about $2,000 you should be able to build this easily. And if you're mass producing it, I think $1,000 or less you could do it. You can manufacture it for less than $1,000 if you're making many of these. Okay, so does this give you an idea of, like, the kind of thinking that you should put, like, when you're designing your product? uh, yes, no.
Yes.
Okay, good, awesome. Let me just say, and it will say, and I think you should be able to import the files even if you are going to use Onshape. Onshape also accepts the step file from whether it's McMaster or any of the other. uh, catalog folks.
Yeah.
Okay, so this, okay. Now the next thing I wanted to know, like, how much knowledge of electronics you have. Like, hey, I think you guys had, you all had participated in FTC last year. Is that right?
Yeah.
Okay, good. What's the plan for this year?
FTC again.
Okay, awesome. Uh, okay, let's see who's there. Somebody's trying to join. What was that? Yeah, who's this garbage man? Hmm, okay. Yes. Hey. How much knowledge of electronics do you have? Like, have you worked with Arduino or any of those other modules?
I have working knowledge of
Okay,
electronics.
okay, okay, good. So, mm, let me see there. Okay. So,
Since
yeah. So
uh,
you you could also consider, if you want to add any electronic feature to it, and we will see, like, if when we are going to make the product, maybe if we can control the electronics, or we can uh, write a small code on Arduino and add improve the utility, we should consider that as well. If you have working knowledge, great. Uh, we should be able to help you, like, write some codes as needed. Somebody was asking a question.
oh, like I was about to ask like so. No, no, I forgot my question.
Okay, okay. Feel free to stop and ask, like, whenever that question comes back to you. Okay, so so this is uh, so I talked about, like, the whole process of product design, uh, like material choices, meeting utility, and keeping the cost reasonable. I also discussed, like, under I also inquired, like, if you about knowledge of electronics. Okay, so with that, I would suggest, uh, how about, I was expecting, like, other students to join, so that we can discuss their ideas as well. So, but since only we had two students, and I think uh, one more student just joined. Uh, at this point, I would like to end this class. Okay. Uh, because I thought, like, most of the time will be into discussing, like, the ideas from four to five, all the students, if they could join. But definitely, if you can, before the start of the next class, the write-ups which I mentioned, if you can send it to me, that'll be great. Like, hand sketch, picture, material that you will use, problem that you are going to solve, and the cost. The ideas that you discussed is perfectly okay too, but if you can think of any other idea, we will discuss that as well. Sounds good?
Yeah.
Okay. Okay. So we will continue next time. So, uh, okay. That's all I have for this time now, in that case. Okay.
Okay.
Okay. And I will share this discussion also. And if you are interested, I can share this model also. It's pretty cool. That is step file for this bicycle based car. Okay. But do let me know if you're interested. I will share that model. Okay. That's it for now, and we will continue next time. Have a good rest of the week.
No.
Right.
Okay. Bye.